In the homework, this is the statement that you want to prove. Show that this Qn, this a new number constructed by defined by n factorial plus 1, contains a prime factor greater than n. And then use this conclusion to conclude that there are infinitely many primes. Well, I would like to clarify that all you need to prove is to prove this statement, the first statement. And once this statement is proved, you know, it has a prime factor greater than n. There are infinitely many n, right? You can choose any n you want. Therefore, we can conclude there are infinitely many primes. And also this prime is greater than n, so this prime is approaching infinity as well. Because n can be arbitrary number, it can go to infinity, and this prime has to be greater than n. So there are infinitely many primes. So this result comes after this statement. Therefore, some of you, when you prove that, you assume there are finitely many primes. That's not what we want to assume. This conclusion comes right after this is proved. So we don't want to prove this one. This can be concluded after this statement. So maybe for now, forget about that, right? Because once you prove this statement, this automatically follows. Therefore, you want to prove this one. You don't want to prove, I mean, essentially you want to prove that, but you just focus on proving this. Now, how do you prove that? Proof by contradiction is nice. So you're going to suppose this Qn, suppose the opposite, right? The opposite is means contains no prime factor greater than n, i.e. all prime factors of Qn, they are less than or equal to n, right? That's its equivalent statement. Let's say P is a factor of Qn in this case, well, where P less than or equal to n, right? Because that's basically coming from the assumption, which means, i.e., P divides this Qn. That's what we know. That's from the assumption. Now, P also divides n factorial. Why? Because P is less than or equal to n. N factorial must contain P. And from there, from these two, you can conclude that P divides Qn minus n factorial, which is a linear combination of Qn and n factorial. And this is, what is Qn? Qn is n factorial plus 1. So when you minus n factorial, this is 1. That's where the contradiction comes from, which means P divides 1, a contradiction, right? Therefore, you can say Qn has a prime factor greater than n. And therefore there are and you can say, since there are infinitely many options, right? Infinitely many choices for n. Therefore, there are infinitely many primes. That's how I would prove this problem.